so what we just did was we started with the zeros of a function, and we went backwards and wrote the function. Now, the directions will say of least degree, because at any of these roots, the function could bounce, or the function could squiggle. And in that case, we would have squares and cubes and but if I tell you of least degree, we'll always go with the smallest degree. Okay? All right, this one, number 2. See, take a second and see if you can set it up. Front is.
Right in the even box.
We're gonna do them all.
This and this?
No, we're skipping the evens.
I don't even know if it's you have to put a zero on
You do not have to.
there.
Okay? So, couple questions about the zero. Do you have to write x minus 0? No. You can just write x. So x times, what would this one become? Plus 4. And then this becomes x minus 3. All right, so here's my factored form. I'm already there. Now, expanded form. What you want to do is you can only multiply 2 factors at a time. So I'm going to pick these 2 because they look alike. And I'm going to start with those 2. It's always nice to pick things that look similar and start there. So here I get x squared minus 3x plus 4x minus 12, which simplifies to x squared plus x minus 12. Okay, now we are completely done multiplying these 2 factors. So you pick 2 factors and start with just 2. Don't try to do more than 2 at once. You'll end up with a big wrong mess. Okay, so 2 at a time. Now we're going to distribute this term through this one, and then we'll have our expanded form. So it becomes x cubed plus x squared minus
12x.
12x.
Appreciate the luck we do.
Okay, so right here, what would change? What would change if we had a double root at 0? What would change? How would this look different? If everything else was the same, but it told us they had a double root at 0. It would have to be squared. So we'd start off with x squared, and then this, and then this. You got it? Okay. Now, number 3 is where everybody needs to pay attention, even those of you that are trying to work ahead on the homework. Okay? Yeah. All right. Number 3 has fractions, which aren't a big deal. When we start with this, how did we get this answer? Well, we took the factor, set it equal to 0, and solved. So we can just go backwards. Let's make this thing equal 0. Well, we're equal to 2. Got a little more work to get to 0. Now, isn't this where we started to get x equals 2/3? So if we have 2/3, then our factor was 3x minus 2. Does that make sense? Okay, now, those of you that really kind of like math and you pick it up really quick, here's a shortcut. Every time we took something in this form and solved it, we'd have to subtract b, so it'd become negative, and every time we would divide by a. So this always ends up being the opposite of the constant divided by the coefficient. So we could go straight from here and do the opposite of the constant, and here's my coefficient. Do y'all see how that works? Now, if you don't see how that works, totally fine. Let's do it the way we just did. We want to make this equal 0, so we're going to multiply by the 4. And then we're going to move the 1. Hey, did I get the same thing? Yeah.
Looks like it.
All right, so you can do it either way. This is factored form. You would probably write them closer together. That kind of looks bizarre, that far apart. Oh, I didn't grab it all. See if I can grab it all and slide it on over. A little closer. There we go. That looks better. There's factored form. And then we just distribute to get expanded form, so we can do that quickly. 3x times 4x. 12x squared. And then 3 times 1 is positive 3x. Negative 2 times 4 is negative 8x. And negative 2 times 1 is negative 2. So this simplifies to 12x squared minus 5x minus 2. Good. All right, last two before you're on your own. You'll have the rest of class to work on the sheet. And every class, almost half the class is finished. All right, so here we have x equals 2 and x equals I. All right, guys, if one of them's I, what has to be there if I is 1? Negative I. So even if I don't write it, you know it's there. So when we start doing the factors, f of x equals x minus 2, x minus I, x minus negative I becomes plus I. All right, I said you can only multiply 2 at a time, and we want to start with the ones that are similar. Well, when we have conjugates, we're going to always start with those, because nice things happen when you multiply conjugates. So x times x gives us an x squared. X times I is ix. X times negative I is negative ix. And negative I times positive I is negative I squared.
Positive 1.
Which becomes positive 1. Good. That doesn't look like 1. There we go. Now what happens to these?
They cancel.
They cancel. So this gives me x squared plus 1. Now I multiply that times
X minus 2.
x minus 2. And that'll take me to expanded form. Now, I'm going to kind of do this out of order, because with expanded form, it always goes from greatest degree down to least degree. So I'm going to do the x times the x squared, because that gives me my greatest degree. But then I'm going to do negative 2 times the x squared. And then I'm going to do x times 1. And then I'm going to do negative 2 times 1. And then that way, I'm in the right form. Saved myself a step. Make sense?
Yes, it does. Makes sense.
All right. So, while you're working on this worksheet, I'll be happy to help anybody that has number 5 written down as an example. If you don't write down number 5, you don't get help. Yep, I got you. Okay, so 5's got negative 1, positive root 5, negative root 5, positive 2i, negative 2i. Even though it's not written, it's there. All right. So it's going to look a little ugly. X plus 1, x minus root 5, x plus root 5, x minus 2i, x plus 2i.
But
you can only do 2 at a time.
But you can only do 2 at a time.
So it's going to take a
Can
long
you do
time.
both the conjugates?
So I would do those 2 to start with. Or these 2. You could go either way. Let's do these 2. So we get x squared plus root 5x minus root 5x minus, what's root 5 times the square root of 5?
25.
The square root of 25, which is 5. Now, how many of you have noticed every time we multiply conjugates, that cancels? Some of you will probably even skip writing that down because you know you're going to be left with this. I'm good with that. All right, so those were my first 2. I can only do 2 at a time. I just did 2. Now let's do 2 more. I'm going with these 2 because these are also conjugates. So I'm going to distribute the x, and I get x squared plus 2ix. Then I'm going to distribute the negative 2i, negative 2ix, minus 4i squared.
So plus 4.
Very good. That becomes a plus 4. These go away, and I am left with x squared plus 4. And then I got this one I hadn't touched yet. All right, I gotta keep working. And I can only multiply 2 of them. And I'm gonna do the ones that look similar. Which ones look similar?
The 2 on the right.
The 2 on the right. So that gives me x to the 4th
4x squared.
plus 4x squared minus 5x squared minus 20. Which is x to the 4th minus x squared minus 20. Finally, the last 2.
This is really fun.
I agree.
Lots of multiplication.
X to the 5th minus x cubed minus 20x. All I did was distribute the x through. Now we have to distribute the 1 through. So that gives me a x to the 4th, a minus x squared, and a minus 20. Now some of you probably would have noticed, ooh, I can put these in the right order to start with. Do it. I've got to rearrange mine a little bit, go from greatest to least degree here so that I have my answer in standard form. And we're done.
Sweet.
Okay, front side, you got the rest of class. You are welcome to listen to school appropriate music if you have earbuds. And you may certainly ask questions. If I were you, I'd start with the harder ones so you can ask me while you're in here.